yesterday marked a monumental moment in the world of AI. Speculation was rampant that OpenAI had essentially achieved AGI, artificial general intelligence, and even some OpenAI team members supported this claim. However, a fascinating discussion recently unfolded on Twitter, challenging the validity of this AGI benchmark demonstration. The debate sparked when a tweet caught everyone's attention, suggesting that what we witnessed might not be what it seems. I'm getting GPT-4 vibes from this announcement, when in March 2023 we had some massive progress, and how did they get such a jump in AGI? Then this person Niels Raj responded saying, they did this by training 75% on the training set. And this refers to something OpenAI mentioned earlier, where they stated that they trained the model on the 03 training set and tested it on 75% of the public training set. They also clarified that they haven't shared further details. Specifically, this information comes from the AGI webpage, which discusses the O3 results. It notes that OpenAI trained the model on the 03 training set, tested it on 75% of the public data, and hasn't provided additional details about the process. Furthermore, they haven't tested the ARC untrained model, so it's unclear how much of the performance can be attributed to the ARC AGI data. We also heard from a notable AI critic, Gary Marcus, who reacted by saying, "Wow, if this is true, it raises serious concerns about yesterday's announcement." This statement refers to the possibility that the model might have been trained on the same dataset it was evaluated on, potentially exposing it to examples it shouldn't have seen. Interestingly, someone pointed out that during the 03 presentation, there was an interesting slip-up. The engineer mentioned they had specifically targeted the ARC benchmark, but Allman immediately corrected him, clarifying that nothing special was done. Allman emphasized that there's no reason for him to comment unless it's a lie, and he essentially has nothing to say about it. Now, what he's referring to here is what's known as a Freudian slip, which is similar to what's called an Allman slip. This happens when an unconscious thought influences what someone says, causing them to say something they didn't intend. Let's take a look at this brief clip, which I think is quite interesting. As this video progresses, you'll begin to notice that the claims lack strong support.
It's also a benchmark that we've been targeting, been on our mind for a very long time, so we're excited to work with you in the future.
Worth mentioning that we target and we think it's an awesome benchmark. Yeah. We didn't go do specific work for this. This is just the general of three. But yeah, really appreciate the partnership. And this was a fun one to do.
The clip was referring to a statement where the engineer mentioned that they targeted the benchmark, but Salmon clarified that they didn't. One of the co-creators of the ARC AI benchmark has responded to this and explained that they addressed the confusion around the ARC-tuned model. He mentioned that they trained the model on 75% of the public training set, which is specifically designed to expose a system to the essential knowledge priors needed to perform well on the much more challenging private evaluation set. The purpose of the training set is to introduce individual priors, and the evaluation set requires systems to recombine and abstract from those priors on the spot. Essentially, the evaluation tasks demand that the benchmark creators use 3 to 5 priors, and the evaluation sets are designed to be resistant to systems that simply memorize the training set. This is why the 03 model is considered impressive. He also mentioned another reason why he believes this doesn't matter. It's almost certain that the ARC's training set, as well as the evaluation set, were part of the pre-training for GPT-3, GPT-4, and GPT-40, since these have been publicly available on a GitHub repository since 2019. The most surprising part is that these other models don't seem to perform particularly well on the ARAGI benchmark. This suggests that if the data was included in the pre-training, GPT-3 might represent a different kind of breakthrough. In that case, we would have expected models like GPT-4 or GPT-40 to perform much better on those benchmarks. Someone else pointed out, "Where's your result without this dataset? What's the scientific value of this number if you acknowledge this limitation?" And the response was that they wanted to conduct an ablation study, but didn't have enough time before the announcement. However, I still believe this doesn't detract from the fact that O3 is an exceptionally capable system. This is a point I agree with. When we examine what O3 is truly capable of, which I'll discuss later in the video, it becomes clear. It seems that this is the point where franchise CH decides to respond to the other individual who created the ARC AGI benchmark. They mention that this is the training set point where the model is trained on it. However, it would have been more impressive if the model had no prior exposure to the ARC data. That said, the fact that the model was adapted using the training set does not invalidate its score. As you can see, the creators of the benchmark also agree that this does not affect its score. Of course, we're going to have prominent AI critics like Gary Marcus who will voice their concerns. As I've always said, it's essential to have balanced discussions around AI. This is how progress is made, rather than just getting caught in the hype bubble. Through honest evaluation of our flaws, we can better understand how to improve. The goal should be to ask ourselves, if this isn't true reasoning, how can we reach genuine reasoning and ultimately achieve true AGI? There's more to consider here, as many people have missed the point on this matter. You can see here Rune, an OpenAI employee and part of the technical staff, commenting that, oh man, they trained on the OpenAI response dataset, it's all over now. He's clearly being sarcastic, implying that this isn't actually the case. Now, if we take a closer look at what's happening here, we can examine what this individual who is conducting research at OpenAI has stated. The model we used for all our 03 evaluations is fully general, a subset of the ARC. AGI public training set was a tiny fraction of the broader 03 training distribution, and we didn't do any additional domain-specific fine-tuning on the final checkpoint. This is in response to a tweet from someone who works at OpenAI. They asked whether the high AGI score is a result of how we prompt the model. I came up with a prompt format that I thought was clear, and then we used it. And that's the whole story. As you can see, the team at OpenAI has confirmed that no additional domain-specific fine-tuning was done on the final checkpoint. I know many people might have assumed that because the model was labeled as tuned, it meant they fine-tuned it specifically for that benchmark, but that's not the case. You might also hear someone say here, were anyone on the team aware and thinking about ARC and ARC? Like problems as a domain to improve at when you were designing and training 03. This is the distinction between succeeding as a random side effect or succeeding with intention. Of course, this could be referring to the idea that you can target a benchmark, which is often the case when people are trying to develop these systems. As you can see here, he mentions that the team wasn't focused on ARC while training 03. Internally, people just view it as one of the many well-designed evaluations that help track real progress. Someone mentioned here about the term tuned, asking what it means in this context. One of the researchers at OpenAI responded, explaining that it's a peculiar way of indicating that we included additional training examples when training GPT-3. However, it's not a fine-tuned version of GPT-3. It's still the original GPT-3. This distinction is really important because fine-tuning involves training on specific data, which is very different from just including that data in the original training set. So there's definitely some confusion caused by this unusual way of presenting it. I'm assuming the team internally wasn't intentionally trying to target that benchmark. It seems more like an unintended consequence. Whether that's accurate or not is ultimately for you to decide. With all this information, and with some people claiming that they did aim for the benchmark while others argue they didn't, citing various examples and reasoning, it's up to you to weigh the evidence and form your own conclusion. We clearly see that, we have both creatures of the benchmark basically saying that, this doesn't invalidate its score. Of course, the evaluation sets are designed to be highly resistant to simply memorizing the training data, which makes GPT-3's performance all the more impressive. Even if, and I don't believe this to be the case, it were purely based on memorization, it would still be noteworthy. However, as I mentioned, I don't think that's what's happening here. O3 is still an impressive system, and here's why. This is the Epoch AI Frontier Math Benchmark. Previously, state-of-the-art systems only achieved a score of around 2%. However, O3 has surpassed expectations, achieving over 25%, which is truly remarkable. These frontier math results highlight a significant leap in capability. For those who may not fully grasp the magnitude of this improvement, it's an extraordinary achievement that sets a new benchmark for AI systems. Terence Tao, widely regarded as one of the greatest living mathematicians and a Fields Medal recipient, is also a professor at UCLA. He once remarked on this benchmark, stating that it posed immense challenges and believed it would likely resist advancements in AI for several years. This was his perspective when the benchmark was initially introduced. we can already observe that 3 is a system achieving an impressive 25% performance. Keep in mind, this is OpenAI's second iteration of the model, and it's performing remarkably well on a highly challenging benchmark. What's even more fascinating is that this benchmark is designed to resist memorization, given the limited amount of data available. Take a look at what they mentioned in the video uploaded to their channel. Interestingly, most people seem to have missed this detail, as the video has only around 300 to 400 views.
Existing benchmarks for complex scientific reasoning are close to saturating. We need something new to be able to tell how much progress we're making towards expert-level ability. And that's why we've built Frontier Math. We worked with over 60 mathematicians worldwide, professors, IMO writers, and Fields medalists, to produce hundreds of original, extremely challenging math problems.
These are actually genuinely hard problems. One of the things that will be, I think, difficult is like a lack of training material. Like pretty niche, it's probably not that well documented.
Yeah, so I took a look at the 10 problems you sent. I think I could do the analytic number theory ones in principle, and then the others I don't know how to do, but I know who to ask.
The problems of Frontier Math range in scope from Olympiad-style puzzles to research-level challenges and span across all the major fields of mathematics. They're also beyond the capabilities of current AI. We've tested the most advanced systems available, and each succeeded in less than 2% of these problems.
In the near term, basically, the only way to solve them, short of having a real domain expert in the area, is by a combination of a semi-expert, like a graduate student in a related field, paired with some combination of a modern AI and lots of other packages and things like that.
Although Frontier Math measures advanced mathematical reasoning, we use problems with closed-form answers like integers so they can be automatically verified without significant advances in the math libraries of proof assistants. This is a challenging design constraint for the mathematicians writing these problems, whose research is almost entirely conveyed through proving theorems. An AI capable of solving this challenge will have a drastic effect on mathematics.
This should give you a clear indication that even if there were some minor issues, very minor ones, with the OAI benchmark, the system still managed to achieve 25% of the benchmark. In comparison, the 01 Mini and 01 Preview only reached around 1%. This highlights just how drastically different this system is in terms of its capabilities. Now, whether you agree with that is entirely your call. There will always be AI skeptics, and honestly, that's a good thing. Skepticism fosters constructive criticism, which is essential for making real progress beyond the hype. I made this video to clear up some confusion because there's been a lot of debate about whether the demo was fake or if the benchmark results were legitimate. Thanks for watching. Don't forget to like, comment, and subscribe for more updates on AI and tech. See you in the next video.